Hi everyone, we're back with another video about rational functions, and in this one I want to look at them graphically. So if you haven't watched the previous video where we talked about zeros in rational functions, I would go back and watch that one because I'm going to talk about the function that we looked at the last example in that video. All right, so that function was this one here, p of x. It's x times x minus 1 divided by x plus 2 times x minus 1. And so what we wanted to think about was, well, what happens when x equals 1? And so what we saw was these terms right here, right? So this x minus 1 and this x minus 1 actually end up canceling each other out. So what I'm going to do is I'm going to go back. I'm going to go and look at the points on my function. So if I just come along here and I just look, I just sort of click on different points, it's going to tell me what the input-output pairs are. And I'm going to try to get over here to 1. Right, so let's zoom in. Let's see if we can get over here at 1. And so see how we're at 1 undefined. It says undefined. So this is what we call a hole in our graph. Now, if I come over here and I ask Desmos, what is p of 1? It's going to tell me that it's undefined. So if I plug 1 into this function, what I'm getting is 0 divided by 0. Okay, so this is a problem. And since x minus 1 appears once in both the numerator and denominator, we get this hole that's happening. See, we have a hole. Now it doesn't show up. It doesn't show up because it's so tiny and small that what Desmos is doing is it's plotting all these other points around it. And that's why we have to go searching for it. So if I click right there, 1 undefined, we should see a hole in our graph. All right, so one of the things that I want to explore with this function is if I have something of the form 0 over 0, do I always get a hole in my graph? And so you can see at other places when you divide by 0, like over here at 2, right? So if we zoom in, we see at negative 2, I'm going to divide by 0 because I have an x plus 2 term in my denominator. But then we get this other strange behavior happening. The name for that behavior is called an asymptote. It's called a vertical asymptote. And so finding the zeros in your denominator is a good way to identify potential candidates for vertical asymptotes. But we see here, negative or positive 1 is also a 0 in my denominator. It's not a vertical asymptote, it's a hole because it shares that factor with the numerator. All right, so here's what I can do. All right. So I'm going to start changing this function around. I'm going to add extra copies of these factors. Okay, so what I did here is I added another x minus 1 term into my numerator. So I have a 0. So 1 is a 0 of the numerator with multiplicity 2. It's in there twice because it's squared. So when I do that, if I scroll around, see if I can find this point again, 1 undefined is still there, right? So 1 undefined. Right, so if I continue to do this, I could add more. Zeros in my numerator, right? So I have now 1 is a 0 with multiplicity 3. This one might be a little bit trickier to get, but let's see, is it still undefined? It is. So what I'm doing is I'm playing around with this to see if I can get something else to happen. And it turns out that if I just keep adding more zeros, right? So if I add a higher multiplicity in my numerator, it didn't really do much, right? So I still have a hole in my graph. But let's go ahead and let's do the same thing with our denominator. Let's add in another 0. So 0 So positive 1 is going to be a 0 of my denominator with multiplicity 2. And in this case, something did happen. So if I zoom in here and I look graphically, it looks like at positive 1, I don't have a hole in my graph. I have this other thing happening. I have a vertical asymptote, it looks like. So it looks like my graph is sort of, my outputs are getting bigger and bigger. They're going off to infinity at these points. We call that a vertical asymptote. So by exploring this way, what we're able to do is make some observations. And it seems like when you have the form 0 over 0, so what that means is your numerator and your denominator share a factor, right? So they're polynomials and they share a factor, they share a 0. You're going to get the form 0 over 0, and there's really two things that are going to happen, right? So either you're going to have a hole in your graph, or you're going to have a vertical asymptote. And so it depends what's going on. So if the 0 appears with a higher multiplicity in your denominator, right, so see how we have a square in our denominator, x minus 1 is down there more times, you're going to get this vertical asymptote. But if you if the 0 appears more times in the numerator, right, so that x minus 1 term, when it appeared more times in the numerator, we just had a hole in our graph. And so through our worksheets, we're going to explore this a little bit more. How do I identify vertical asymptotes? How do I identify holes? But hopefully this helped out a little bit here, just to see these things graphically. So the last thing that I want to show you is, let's go back to our other function, right? So this is the original function that we were looking at. And I said it's going to be the same thing as looking at the function x divided by x plus 2. Okay, so x divided by x plus 2. You'll notice that the green line and the red line really are the same thing. Okay? Okay. So let's give this another name. Let's call this g of x. So g of x is x divided by x plus 2, and p of x is, we have these additional x minus 1 factors in the numerator and denominator. So the only spot where these two functions differ is when you plug in 1. So if you notice that at p of x, if I plug in 1, I get undefined. But g of x, after I canceled out those terms, x minus 1 and x minus 1, we can actually plug in 1. So if you're going to take a rational function and start canceling some of the common factors, you do have to be careful about your new domain. So you have to take into account that you are going to have holes or other things happening at those points. All right, so I hope this helped, looking at things graphically. In the next video, we're going to talk about vertical asymptotes, holes, and how we can do them algebraically. See you then.